All right. Hey guys, Miss Harper here, one of your favorite algebra teachers. Today I'm going to be working through the exponents test review with y'all. So let's go ahead and just dive in. First one is we're going to be combining like terms, adding and subtracting polynomials. I'm actually going to skip one. Be careful here on number 2. You got to distribute that negative, and I'm going to show you guys how to do that actually here on number 3. So on number 3, we have to distribute a negative here as well. So I'm going to rewrite everything. I have 8x plus 11 minus 9x plus 7 plus 4x minus 13. All right, so again, important thing to do is make sure that anytime there's a negative or a minus sign, make sure you distribute that. All right, and then from here I can just combine like terms. I have some x's here. And so let's see, 8 minus 9 would be negative 1x. Negative 1 plus 4 would give me positive 3x's. And then I can look here at my whole numbers, combine those. 11 plus 7 is 18. 18 minus 13 is a positive 5. And that would be our answer on that one. All right, we're going to look next door here at number 4. One more time, we're going to distribute. And so we're going to end up with 5x squared minus 2x minus 1 minus 3x squared plus 5x minus 7. And then we're going to play the same game where we combine like terms. Remember, whenever we're just adding and subtracting, we don't have to do anything weird to our exponents. We're just combining them as is. So 5x squared minus 3x squared, I get 2x squared. Negative 2x plus 5x is a positive 3x. And negative 1 minus 7 is negative 8. Now don't forget, if you put yours in a different order than mine, that's okay. But however, official mathematicians will always list their answer according to the power of the exponent. So we have the highest power listed first, and then so on. All right, let's slide down here. Let's take a look at our exponents, starting with number 5. Lots of ways to do this. Your teachers are teaching you lots of different ways. Now you could distribute power to a power right here. But for me, I just tell my students to list it out in expanded form. I think that's the easiest way of seeing that. So this is 5m to the 9th 2 times, right, to the 2nd power. So we can write it out that way. Our whole numbers are going to multiply together. Whenever we do that, 25 times negative 10, we get negative 250. And then we can look at our m's, where we're multiplying things of the same base. We add their exponents. 2 plus 9 is 11. 11 plus 9 is 20. So we get m to the 20th power. Awesome. Let's check out number 7. Now we're kind of skipping around here, but you can check out the answer key to check your other ones. So 6x squared. So we're going to take this. Again, you can distribute this exponent if that's what you like. So that would become 6 squared, x squared, and you can simplify that. For me, I'm going to show you guys this in expanded form again. That just means 6x times 6x. 6 times 6 is 36. X times x is x squared. And I can take this one step further and simplify it again. 36 is going to stay as is. There's nobody for him to reduce with. Now my x's are going to reduce. I have x squared and x to the first. So that is going to become x to the first. Whenever I apply my quotient rule, we subtract those exponents. Remember, this is x to the first power. And then my y to the 7th doesn't have anybody to play with, so he's just going to stay chilling downstairs in the denominator. All right, let's check out number 9. All right, number 9, I'm going to distribute this. So this is for those of you who are just doing the official power to a power rule. Now, if you like expanded form like I did up here, you can do that. Just write this expression out 6 times and then multiply straight across. All right, so power to a power tells me to distribute or multiply our exponent. So that's going to become x to the negative 18 and y to the 30th. Now we're not allowed to have negative exponents, so what can I do to make him positive? Well, we can take him and move him downstairs into our denominator to make him positive, and that is one of our exponent rules. And it would become y to the 30th over x to the positive 18th power. Last one on this side, we're going to check out number 10. All right, number 10. Also, I'm using pink and purple because it's Valentine's Day. Woohoo! Okay, so first we can always, first thing I look at this, and right off the bat, I notice these negative exponents. So for my classes, again, there's lots of ways to do these, but my students, I tell them to move them to make them positive. So right off the bat, I'm going to get rid of him and move him downstairs, and now he's positive. And same thing with this guy, except he's going upstairs to become positive. And then I can evaluate this all. If you like to see this in expanded form, you can totally do that. Write out everything. You can see it really well. Me, I'm just going to apply the quotient rule and do all division. So I'm going to do 12 divided by 3, and we get 4. X to the 6th divided by x to the 2nd. Remember, whenever we're doing the quotient rule, we subtract their exponent. So we're going to end up with x to the 4th. Our z's, now this is where you got to be careful. All right, if you subtract them up to the top, you'll end up with a negative. So instead, I want to subtract them down to the bottom by doing 3 minus 2. So I'll end up with z to the first power down there. And then our y's can play together. And again, we're going to subtract these exponents. So 6 minus 4 will stay positive up here. All right, and again, if you're having a hard time with that z part, remember z squared over z to the 3rd power. You can kind of see how these guys will cancel off, and you'll end up with z, but he's downstairs in the denominator, so he needs to stay down there in order to stay positive. All right, and just to throw out number 11 real quick, anything to the 0 power, those are our favorites. Just 1. Anything when the entire thing is being raised to the 0 power, it's just 1. All right, let's check out the back. Okay, number 12 is pretty easy. I would set this up, so if we're talking about a rectangle, that means we have 2 lengths and 2 widths. So I would do this plus this, or you can just write out each thing 2 times and combine like terms. So y'all can check the answer key for that one. That one was pretty easy. But however, I am going to check out number 13 with y'all. So let's look at 13. So this is the total perimeter, and it wants us to find the length of this missing side. So this is what we're going to look for. So if we know what the whole perimeter is, what I can do is figure out what we have so far, what this plus this is, and then I can subtract it from my total perimeter to see what we're left over with to find this missing side. So let's find out what we have first. I'm going to do that by combining like terms. X plus 8x, I get 9x, and negative 8 and positive 4 is negative 4. So I'm going to take my total perimeter, 12x minus 7. Now this is where a lot of kids are going to get messed up. You need to put this part in parentheses and distribute your negative sign. So I'm taking the total perimeter and I'm subtracting the part that we already know. All right, so do that and then we can combine like terms. So I get minus 9x plus 4. And now I can combine like terms. I have 12x's here, negative 9x. So 12 minus 9 is 3x. And then negative 7 plus 4 is negative 3. And that would be my missing side. And I could check that. I could double check myself by going around combining like terms and making sure that it does go back to my given perimeter. All right. Let's check out number 14. The area of a rectangle is this. The length is this. What is the width? So let's first figure out how do we solve for the width. If I know that area equals length times width, and I'm trying to get the width by himself, I'm trying to solve for W. Well, what operation is happening here? Multiplication. Yes, so to do the opposite operation, I'm going to divide both sides by the length. He goes away over here, and I'm left with the width is equal to the total area divided by the length. So now I'm going to plug that given information in. I have the total area divided by the length. So I can find the width. And so we're just going to use our quotient rule properties. 81 divided by 3 is 27. If I use my quotient rule on my x's, that's going to give me x to the 4th because we subtract their exponents, and y to the 2nd. And everything will stay upstairs. Nothing needs to go down into the denominator. These last couple are just review problems. I would probably really easily do this one in the matrix using your calculator. Now, if you wanted to, you could also maybe set this guy up for like elimination. You can multiply the top by -4 to make that -4x to cancel with your +4x, and you can solve that way. I'm actually not going to solve through that. If you need a refresher, go back and check out a Unit 5 video. The coordinates for the y-intercept, to find a y-intercept, that's whenever we plug in 0 for x, which you can see that by all of the given answer choices. All of the x values are 0. So if I plug in 0 for x, 4 times 0, plus 2y equals 10, then I can solve for y, which is a pretty easy one there. Hopefully you get y equals 5. All right, and then our last one, I'm just going to help walk you through this. My first step I would do is find the slope of this line. All right, this is x1, y1, and then x2, y2. So I can find my slope. Once I know what my slope is, then I can pick a point, doesn't matter which one, and plug it into my point slope formula. All right, and that's the point slope formula. Whenever you do that, yes, you will get a fraction, but it's okay. Use your calculator, math, enter. Fractions are friends. Don't be scared. Yeah, you'll find the right answer. All right, guys, good luck on your test. If you have any other questions, go see your favorite algebra teacher. Woo!